In this episode, I'll be discussing the features of an acoustic camera. This is Noise Engineers podcast video, brought to you by Noise Engineers, an independent acoustical consulting firm at noiseengineers.com. We provide you with knowledge and resources to address acoustical issues. I'm Bill Holliday. Thank you for joining me on this episode. I'm going to present a bunch of videos of the display screen for an acoustic camera and of the acoustic camera setup. Here's the acoustic camera. This has 256 microphones in this matrix with a camera in the middle. It's able to record videos or still photos. It has the spectrum, and we'll go over the abilities of it. It does have a battery pack, so you can walk around with it, take it through outside or in a factory. I guess that's it. It connects to a computer.
All right, I am going to show a demonstration of the acoustic camera. We are looking at the panel. I just have my telephone with a white noise source on the other side of this wall. So the biggest path is going to be just over the ceiling. It's going to move around because I'm talking as well. But the acoustic camera, this is the display that you see. You do get to select the frequencies you want to observe. You select the resolution of the contours, and you can make them just contour lines, or you can have the colored for intensity or for the levels, the noise levels. You can make the resolution very small, the space between contours very small, and be very exact, or, well, not that it's more exact, but have tighter resolution or have tighter difference in levels. You can also stretch that out as far as you want. Now, the noise level difference between this hot spot and this spot might only be a couple, 3, 5 dB or so. So, this isn't the greatest example, but you can also block out the noise source, omit that source. It looks like the major path is being reflected over the top. And if I suppress that point, you can see where secondary sources are. So if I tighten the resolution, and you can see that the omni, or the total source, you're getting a lot of noise from that voice, but the total source is 60 dB. The beam is 51-ish. So it's not that this is the majority, but just for an example, if you block out that part, then you see where secondary sources would be. You do have the choice of having this in color, or you can use still photos, do color or black and white. And sometimes black and white is easier to see the contours. Now in this case, we could be in color because it's pretty mild colors. They're pretty passive, but you end up getting usually better resolution or better clarity when you do black and white. You can specify, where you're looking. You can do this all post-processing as well. You just record, and then you can analyze it, take snapshots of it, change resolution, change different parameters, frequency bands, frequencies that you're interested in. So I'm going from about 100 hertz to 5,000 and maybe 10,000. It's just a nice telephone, so it's not the highest quality speaker over there, or loudspeaker. So FFT is a fast Fourier transform that gives you the spectrum of the noise. You can also do third octave bands and full octave bands. A lot of times I like third octave bands because it makes it a manageable amount of data that you're comparing, if you're comparing different things. But if you're looking for peaks, if you're looking for, I have a little refrigerator over there, so that could be provide some peaks at some point. What else do I want to show? Spectrogram gives you kind of a time history of these levels. And I'll close out of that. Maybe, yeah. Frequency mode. You can go for just individual frequencies if you're chasing a tone. If I'm worried about 60 hertz and I want to find out where that's, or whatever, 12,000 hertz, I guess in our case I'll make it. You can find out where that's coming from. This is more of the full frequency span. Again, I'll go around 10,000, start around 100. You can hear this on the computer's output. We have DVA, which is the filter, or the, I guess, yeah, filter, that closely matches, or most closely matches, the human ear. But you can do DVC, you could do just flat decibels, if that's helpful. You can export the graphs. What else do I want to show? I think that gives the gist of it. I mean, the goal of this really is to identify primary noise paths, secondary noise paths, to determine how much noise is coming from primary and secondary noise paths, and get a characterization of the noise. Because this is going to help with determining what kind of treatment you need. If it's mostly low frequency, then you may need thicker absorption or thicker barrier, depending on how much noise reduction you want. If we know the third octave goal and where we are third octave wise, we can find that we can determine how much noise reduction we need in each octave band, and that'll help with determining what type of either enclosure, barrier, absorption that you need to reduce that, or maybe it's treatment to the equipment. You need to put in the distance to the array and the air temperature at the time of measuring.
Thank you for joining me on this episode. I appreciate your watching this. I hope you've learned something. Let me know if you need help with an acoustic camera. You can rent it, you can buy it, you can have us do measurements using it. And thank you for listening to the Noise Engineers podcast video, providing you with knowledge and resources to address acoustical issues. We found this to be a very useful tool. We're looking forward to using it even more on different projects, walls, determining where noise is coming from, environmental projects. So you'll be seeing more of the results from our measurements. I'm Bill Holliday. This podcast has been brought to you by Noise Engineers, acoustical consulting at noiseengineers.com. As always, I appreciate your feedback. You can email me, comment here, subscribe to our podcast, subscribe to our video channel, make some noise on Facebook or Twitter. Just do something so I know you're out there. I'd really appreciate it. Thanks a lot. Take care. Bye.